Thank you very much for waiting. We would like to move on to the next presentation. And the presentation by Mr. Sugiyama and Mr. Oshida, and Mr. Yamaguchi's presentation. Since the time is limited, we don't take any questions from the floor. If you have any questions, please visit to the speakers after their presentations. Mr. Oshida is a computer engineer, and he started the computer engineer career, and he got debut in Ruby, and the test results program has been developed, and then he left Ruby, and in 2015 he moved to Matsu'e, and he's surrounded by Ruby. Mr. Sugiyama in 1976 was born in Tokyo, and he was the meteorology and the geoplanet science is his major, and he graduated from Hokkaido University, and then he joined Kyushu University as a postdoctoral fellow, and he was back to Hokkaido University and joined JAXA. And now he is teaching at the Matsu'e Institute of Technology. And he has been developing a lot of technologies, and the numerical data analysis has been done utilizing Ruby. IoT, Ruby, mruby, and /C have been used to develop the observation system of the meteorology and weather. So today's topic is the commencement of the project and the future perspectives of the project, introducing mruby/C in the Institute of Technology classes. And this is the title of my presentation, and the project here is the project utilizing mruby/C, and it is to be incorporated in the classroom at National Institute of Technology, Shimane Soft Research and Development Center, and Monster Lab and the Matsu'e Institute of Technology are collaborating. I would like to give you an overview, and then later we would like to have several trials we are conducting so that we may be able to have a full-fledged classroom activities next year and after. As was introduced, I am Sugiyama of Matsu'e Institute of Technology. The planet meteorology and the geoinformation is the topic of mine. And the air model was developed using Fortran and was operated, and the result was analyzed by Ruby. This is what I have been doing for years. And these days, I am going to utilize IoT to develop observational system of the meteorology. Why IoT and geoplanet science, you may wonder, and this is my cartoon. In the past, there are a lot of observations. If we want to make some meteorological observations, we have to spend 100,000 yen or sometimes millions of yen to utilize a lot of instruments. However, now we may be able to purchase equipment at a lower cost. So by utilizing IoT equipment, we may be able to make an interesting and exciting meteorological observations. And if we have the budget as we spent in the past, we may be able to distribute those observational equipments at different places, and we may be able to make a very nice study. And that's the motivation of mine. I started working at the Institute of Technology, and OSS literacy is the subjects taught in the 4th year of the National Institute of Technology, and we try to make it as an OSS literacy, and we are going to use this, and we would have a server, and we would construct a server, and the data is to be analyzed statistically, and we also do the visualization of the data. This is what we are teaching students to do. And there are 50 classrooms in the institute, and the classroom has sensors as shown here. And these sensors are used to monitor air conditioning of the classrooms. And as far as we use Raspberry Pi, we are consuming a lot of energy. And next year, we may be able to have a model classroom. So we decided to replace the sensor with the microcomputer. And we would like to ask students to be involved in the programming using mruby/C. And that's the plan for the next year's classroom. And the students will work on that, and then they would do further activities. The objective of the project is that we are trying to incorporate mruby/C into the curriculum of Matsuei Institute of Technology, and we are trying to accommodate the environment so that we can introduce the new curriculum next year. And we are trying to introduce the mruby/C and ESP32 microcomputers. And we try to connect the equipment to make learning boards. And we are trying to improve and prepare the textbooks. Then the textbooks, we have to have a sample code. And program itself is a very good textbook, but we have to have a sample code to be used. And Monster Lab are collaborating with us to develop this, and we have a program for temperature and humidity sensors. And these programs will be available in public as an open source information. And also, we would collect manuals available through the mruby/C hands-on seminars organized in different parts of Japan. However, we have to try testing it out, so we recruit the students, and we have conducted several exercises. And this is something Oshida-san is going to talk at the latter half of my presentation. And these are the activities we did, and what are the ripple effects of this classroom activities? We could have a lot of sample codes, and we could improve the sample codes qualitatively and quantitatively. And the students started to learn by themselves. And since there are Ruby and mruby/C communities in Matsue, they could utilize those opportunities, expanding their knowledge base. So it is easier for them to learn. And what they're learning and doing is expanding. And it would recruit more students to be participating in the activities. And some students, even after graduation, wanted to stay with that activities. So this is the IoT material to be prepared for the elementary school education. And this is the project of the 5th year student. So I think it is very good. We may be able to collaborate with the community to develop human resources. And we would like to continue that endeavor. And however, it is very difficult to continue working on that. So we have to develop a system for the continuous realization of the projects. And for example, we can invite some of the engineers as lecturer, but this is not only at the time they can come to school. There might be other ways that we can utilize the expertise of the experts. And if you have any comments, please let us know. Now we would like to move on to part 2. Now I would like to talk. I am Oshida of Monster Lab. I have only 5 minutes to go. And in part 2, I want to talk about the classroom activities starting next year, but I want to summarize what we did for preparatory work. What did we do and what could we do? And based upon our performance and achievements, we are to plan the future project. And I would like to show you that this kind of activities is feasible at school, and it is not limited to the Institute of Technology. It can be done in the regular junior high schools or elementary schools as well. So as was introduced, I am, this is my introduction. I'm not a real strong Rubyist, but this is my introduction, and as was explained, we have used a microcomputer to do the edge computing or edge measuring. And we use the ESP32, and what is it? And this is 32-bit 2-core, and it is a rather robust system. And we, depending upon the modules, we have 0.5 megabit of RAM, and we have the 4 microbit of ROM. And it is easy to operate, and we can have an operation. And ESP microcomputer has been used already, and M5 Stack is the package where the system was used. And mruby is one of the major features of that program. Module itself can be purchased for 500 yen. It is not very expensive, and we would purchase 900 copies of this. And if some other functions are added, it can be 3 times as high as the price here. And the simplified versions are also available. And it is around $12. And microcomputer development, if they are the words you hear, you may think that it might be very expensive, but we can make a computer for 1,200 yen. So it is not a very difficult system to build and to use. And Linux is used as an environment and for development, and it is too risky to ask them to prepare for the operating or development environment. And so we set the environment, and then we provide the USB or USB to the students. And we would ask the students to read the temperature and humidity sensors. They would read the external RTC, and they would read external RCT. The participants are mostly the 5th-year students in junior or National Institute of Technology. However, when we visited there was the first-year student who was interested in the topic and who was there. And this is the photograph of the classrooms. At the bottom, you can see the electrical pot, water boiling pot. And we are trying to put it in the steam generated by the pot. And all the students, there are 9 students, but all the students could complete that process. And this is the temperature and the humidity, and the sensor is placed above the water boiling pot, and we could control the temperature very well. And this is the performance. And mruby can be used in the Institute of Technology. and we don't have to make any capital rich investment, and the difficulty of using mrubyc is similar to Rwc2019, and we may be able to enjoy several benefits. And this is the assessment evaluation by the participants, and they say that it is enjoyable and it is not very difficult, and there is a sense of achievements after working on it. Then this is the free word comment, and they said that some of the students stated that she wanted to know more about the difference between Ruby, mruby, and mrubyc. And though the actual system we used was mrubyc, we let them use mruby over C under the condition that they feel as if they are utilizing only mruby. Thank you very much for your kind attention.